This is CPE 233, Lecture 19, Example 2, and this is an example of determining how long a certain piece of code takes to execute. So as you know, each instruction requires 2 or 3 clock cycles to execute. So what we want to do is be able to look at the code and determine, how many clock cycles that particular piece of code needs to execute. So we can take a look at that, hopefully. Okay, and so these are two fragments of code here. Obviously, well, you can count the instructions up, et cetera, but you don't want to do that. You want to take a closer look at that, because typically speaking, these problems only become interesting when they have loops in them. So both of these problems have loops in them. And so what we want to do is just, kind of, examine these things, see what's going on. Obviously, there's a loop in this thing here. This top problem here, and it's going to loop, looks like the iteration is going to loop 8 times. Okay, good. And this is probably something similar. Yep, it's going to iterate 5 times. So what we're interested in is the how many clock cycles each instruction takes. So you can kind of wing these and do it in your head, but every time I do that, I get it wrong. So I'm going to put these number of clock cycles out here. So most of these are non-load type instructions would require 2 clock cycles, but if you got to be really careful here, because there's 2 load instructions that are going to require 3 clock cycles. Now I'm not going to even pretend like this code does anything meaningful, because it doesn't. But so I'm not going to look at that. I'm not going to pretend it does something, but I am going to come down here and write all these values down just to get started. So once again, I can do this in my head and get it right 75% of the time, but that's not good enough. 3, 2, 2, 2. So essentially what this is saying is that every instruction that's a non-load type instruction requires 2 clock cycles, so the load type instructions are going to require 3. So let's do this out top problem here. I'm gonna put this clearly aside here. So that is my loop. That is going to execute 8 times. And then, essentially on that 9th time, it's going to come to this instruction here and say, hey, do I need to do it again? The answer is no, but this one instruction here, this compare instruction, this branch instruction is going to hit an extra time past the 8 iteration. So summing these up, I got 2 plus 2, which is these 2. Then I got 8 times whatever's in here. So it's 2, 4, 6, 8, 10, 11, 12. 2, 4, let's do that again. So 6 plus 4 is 12. 12, that's for the loop. So 12 comes from 2 plus 3 plus 3 plus 2 plus 2. Make sure that's right. Okay, so that's the 12. Now, what the 9th time, or the other time through this loop, it's not going to go through the loop, but it will get this instruction here. It will take the branch and down to this one right here. And so this one is this instruction, and this one is this instruction. I can sum those up. 8 times 12 is 96, plus 4 is 100, and I'll say 104. 104 clock cycles. Okay, so it's going to be the same thing in this problem. I think it's going to be, obviously a different iteration count, but it's still the same type of a problem where this is the loop here. All these are going to be done 5 times, but we're going to come back to this instruction and do it an extra time. So I'll just put 6 times for that instruction. And so what we have here is these 2 here, 2 plus 2, and then we come down to 5 plus 5. This is the iteration count here, 5 times, we'll just write it out, 2 plus 2 plus 3 plus 2 plus 2, and this is going to be plus the extra one here, plus 2 and plus 2, which is this bottom one here. So this is the extra instruction that it's going to cause it to jump out of this loop, and we got to include that. So this is 2 plus 2, 2, 4, 6, 8, 10, 11. So this is 55. 55 plus 4 plus 4 equals 63 clock cycles. Okay, so once again, when you see these problems, you have to be careful with them. You have to determine exactly what the loop is doing. And I think that's it. Looks good. Doesn't look good, but that's it.